here we have got a primary amine, that is RNH2. If you add HCl, see it gets this H gets added up here, so it becomes RNH3Cl. So this part is positive and this is negative, so alkyl ammonium chloride. So secondary amine R2NH, see R gets added up for each step. So and at the same time hydrogen goes one less. So for secondary amine it is R2NH plus HCl, you get R2N plus H2Cl minus, this is dialkyl ammonium chloride. For tertiary amine you get trialkyl ammonium chloride R3N plus HCl minus. So example, it is N-propyl amine CH3CH2 CH2 NH2. When you add HCl, for your convenience the reaction HCl is marked as red, so you get CH3 CH2 CH2 N. So this H gets added up here, so H3 and Cl minus, this is propyl ammonium chloride. Then triethyl amine, so here CH3 CH2 thrice N plus HCl, so you get CH3 CH2 thrice, so N plus N, and here gets the plus sign will go and all the things get added up together, it's called triethyl ammonium chloride. Okay, now what are the uses of amines? So mainly it is used to synthesis nylon, making of nylon. Nylon, these are condensation copolymers. How do you get it? Equal part of diamine when it reacts with dicarboxylic acid. So peptide bonds are formed at both ends of each monomer. So you can see the general reactions here. See dicarboxylic acid RCOOH and RCOH, N molecules will be there, plus here you get diamine N molecules. So you have to put that inside brackets. See CO, see this means that this chain is continuing on either side. So COR, CO, NH, R dash, NH plus 2H2O. So this is the structure for nylon. Just remember, don't forget, this is a very important structure. Now next we will compare the boiling points of primary, secondary and tertiary amines. So for isomeric amines, boiling point will decrease in the order, see primary, secondary, tertiary. And why? Because of the decrease in intermolecular hydrogen bonding. So we have got a few examples for primary, secondary and tertiary amine. So this is propanamine, CH3, CH2, CH2, NH2. Then secondary amine, N-methyl ethanamine. So CH3, CH2, N, NH. Okay, so here you attach another CH3. So here boiling point is given 48.6, for this is 37, tertiary 3.5 only, NN dimethyl methanamine. So 3 methyl groups are, CH3 groups are seen around N. So molecular formula is C3H9N and molecular mass is 59. Now salt formation. So reaction of amines and acids will give an amine salt. So amine salt, it is composed of two types of ions. One is protonated amine cation, which is an ammonium ion, then anion derived from the acid. So normally amine salts are ionic, they have got high melting points. Then it's non-volatile because it doesn't form vapors easy. Non-volatile solids which is more soluble in water than parent amines, and slightly soluble in non-polar organic solvents. Next is, you use prefix amino to show the presence of NH2 group in a molecule which has got more than one functional group. So here you can see amino ethanoic acid, for example NH2 CH2 COOH. If it is 2 amino ethanol NH2, here you can write H2N also, NH2 CH2 CH2 OH. So CH2 is getting repeated twice. So this is the structural formula. You can see diaminophenol and aminobenzaldehyde. So all these structures, CNH2 is attached in benzene. Here this is OH, this is phenol, benzene ring attached to OH, we call it phenol. Then in the second and fourth position we have got NH2. So that is why we call 2, 4. Always write the numbers first, number of the position. So this is 1, 2, 3, 4, like that we count. So second position and fourth position, 2 amino groups are there. So if we say diamino, then this whole thing is called as phenol. So here it is position 1, 2, 3. Third position we have got amino group benzaldehyde. Okay, so just remember that. Now, how will you compare the boiling points of amines with other organic compounds? So, the boiling points of aliphatic amines, they are higher than those of alkanes or haloalkanes of similar relative molecular mass. Why? Because of high intermolecular hydrogen bonding. So, NH bond is more polar than CH bond, but less polar than OH bond. Hydrogen bonding in amines are weaker than alcohols or carboxylic acids, and boiling points of amines are less than corresponding alcohols or carboxylic acids. So, if you can compare the boiling points of organic compounds with similar molecular weights, it comes in this order: C alkane, ether, alkyl halide, amine. You know, this is lesser than sign, ketone, then or aldehyde less than alcohol less than acid. So, remember this, write it in a book or take a screenshot of this. Next, tertiary aromatic amines. So, these react with nitrous acid by substitution. Reaction is taking place at para position of benzene ring. We get nitrosoaniline, that is yellow precipitate. You can see here benzene ring and here NR2, 2R. Then in presence of HNO2, you get the structure same NO. So, O gets added to N, and this part is same. See, it is remaining same. Just you have to add ON here. Okay. So, here we call it nitrosoamine compound, which is yellow precipitate. Okay. Next is example. We have got another example here. CH3 NH2. NH2H we are splitting it and write like this, plus CH3 COCl. This is known as ethanol chloride. So, the product is CH3NH. This part we write like this itself. See, then put a single bond, then COCH3. Then this violet color CH and Cl will join together. So, that is why you just add HCl together and write all the remaining part as such. So, phenyl benzylamide. This is ethanol chloride. Okay, now always in organic chemistry you should remember to write the equations and learn. Then what about the solubilities of primary, secondary and tertiary amines? These all three classes of aliphatic amines, they can form hydrogen bonds with water molecules. Then the lower amines with chain length up to 4 carbon atoms per molecule, these are soluble in water because they can form hydrogen bonds with water molecules. Solubilities of amines decrease with increasing number of carbon atoms in the chain, and amines are soluble in organic solvents. Okay, now amines, these are organic derivatives of, as already I said in the beginning of today's session, ammonia with one or more alkyl or aryl group bonded to the nitrogen atom. So, amines N and nitrogen and hydrogen atoms are there in amines. So, functional group, see here, see R is equal to H, this is a hydrocarbon, okay, attached to N. This is the general structure of amines. And classification, primary, secondary and tertiary amine. Okay, primary only one R group here, the 2 hydrogen, here secondary only 1 hydrogen and 2 R group, and for tertiary all these are R group attached to nitrogen. Hope you are following it. This is a very easy chapter. So, after you doing a quick revision, then we will be completing all the units, and then I will be uploading the MCQs, most important MCQs from these lessons. And secondary aliphatic and aromatic amines. So, aliphatic secondary amines, they will react with HNO2 at room temperature to form nitrosoamines or nitrosamines, which are yellow oils. So, R2NH plus see here HNO2, we are writing like this. Between N and O, here we are having double bond, and NOH, this is single bond. So, R2N, then again single bond NO, and this H2O part you have to remove, and that is another product. So, here we have got one example, dimethylamine, 2 CH3 groups are there, H, then OH NO. So, same this reaction, what product we get? Yeah, CH3N, see, just remove that violet H2O, that is all. The product is N-nitroso dimethylamine. Okay, next IUPAC name, which is similar to alcohols. IUPAC names are very important, so they come mostly for the exam, and you have to remember the concepts well, how to identify. You have to take the longest continuous chains of carbon atoms and find the root name depending upon the number of carbon atoms. For example, if it is 3 carbon atom, 4 carbon atom, now butane, 5 means pentane, 6 means hexane, like that. And E means alkene name, it is changed to amine, and the number shows the position of the amino group along the chain. The other substituents on the carbon chain are given numbers, and then the prefix N is used for each substituent of nitrogen. See, look here. So here this is the longest chain, okay, and here 4 carbon atoms are there. So this is butane. So second position amine is added. So we say 2 buta, okay. So amine, butanamine, okay. Here see 1, 2, 3, 4 numbering from right to left. Here why you are numbering from right to left? So here we are having the side chain. It should have a lowest number. If you put 1 here, this will get only second position. So we start 1 from here. But when you write it 3 methyl, this is methyl group, 3 methyl, then first position we got amine, but it is, since it is butane, you write butanamine, 3 methyl, 1 butanamine. So here this case again numbering 1, 2, 3, 4, second position NCH3. So N methyl, this is methyl, then second position 2 butanamine. Here also you can just 2, 4, second position and fourth position NN. So 2 sides we are having prefix N is used to indicate each substituent nitrogen. Okay, so here tetra methyl. So 4 methyl, 1, 2, 3, 4 groups are there, methyl. 3 hexa, 1, 2, 3, 4, 5, 6 hexa amine. So I hope you understood the IUPAC name. Now we will just go through about the basicity of aromatic amines. So aromatic amines normally they are less basic than aliphatic amines and ammonia. Why? Because the lone pair of electrons in nitrogen atom, that is delocalized into the benzene ring. So because of that, the lone pair of electrons is not available, already it is localized into benzene ring. So it is not available for donation to any acid. No? So the reaction is shifted towards the left hand. So it makes aniline a weaker base than ammonia or aliphatic amines. So remember this point. And now naming aromatic primary amines. So aromatic amines have amine group like NH2 attached directly to the aromatic ring. So this ring is known as aromatic ring, directly it is attached here. So aromatic amines are known as aryl amines. Remember, most of the place you will come across the words aryl amines. So here phenylamine, aniline. So 2 methyl phenylamine. So 2 methyl phenyl amino, 2 methyl aniline. Okay, so this structure is called aniline. And 4 here nitro group is included in the fourth position. We can say 4 nitro aniline also. So nitro NO2 is nitro group. So this NH2 that is known as aniline. Okay, now primary aliphatic amines. So when aliphatic primary amines react with HNO3, you can write NO RNH2 plus NOOH. So nitrogen is HNO2 here, it is not NO3, HNO2. Nitrogen gas is evolved in this reaction. Remember the products ROH, this R will combine with this OH, then H2O is formed and nitrogen gas is evolved. So ethylamine here C2H5 NH2 plus HNO2 will give you C2H5OH, that is ethanol 60% and nitrogen gas along with other products is formed. Remember, all these reactions are very important. The reaction of propylamine with HNO2 will produce nitrogen and mixture of 1 propanol, 2 propanol and propene. So see the percentage of each product. The reaction of ethylamine with HNO2 gives you little methanol, and the main products are methoxymethane and nitrogen. Now ring halogenation of phenylamine. So if you add bromine water to aniline at room temperature, bromine water color will disappear and a white precipitate of 2,4,6 dibromoaniline is formed. So this is very important. Most of the NEET exams has question from here. So this is an important test used for aniline, identifying aniline. So 3Br2, you see 2 position 2, 4, 6 tribromoaniline. It's a white precipitate plus 3 HBr. So mainly they will give you some blank space somewhere here and ask you for the reactant or product, like that questions will come for the exam. Now tertiary aliphatic amine. So these react with HNO2 and they produce ammonium salts and it dissolves readily in water as a clear solution. So R3N plus HNO2 gives R3NH NO2. And primary aromatic amines it reacts with cold HNO2 and dissolves in dilute HCl 0 to 5 degrees Celsius. That will give you diazonium salt. And these cold salts, when heated at room temperature, you will get nitrogen gas. See, NH2 plus HNO2 plus HCl at 5 degree centigrade, you will get benzene diazonium chloride. See, diazonium, N2Cl is diazonium chloride plus 2H2O, again room temperature, you will get nitrogen plus the mixture of the products. Okay, now with that we are coming to the end of this session. And